I saw this tweet and I was like, oh yeah, this is it. This is what I like. It's a very short piece of code, very expressive, and it has a cool piece of mathematics. So I was very happy when I realized that actually it was not clear how this works. Okay, so I had to have a second look, and this is what's in this video. Okay, so let's fire up a repo. And the first thing to figure it out what's going on is that, well, actually, let's just copy paste it there. So it was something like iterate, and we composed ink with division, and we took one. Okay, it was something like this, but this will be an lazily evaluated infinite list, so we don't want to print this. Let's just take the first 10 out of this, and it's indeed, these are the ratios converging to the golden ratio. Okay, so how did this happen? Well, let's look at the composition. Okay, so what does comp ink and division does to 1? Okay, that's gonna be 2. Well, why did that happen? Well, one thing is that division has this sort of behavior. Well, okay, if I divide 1 by 2, well, I get 1/2. Okay, that's not particularly surprising, but this works with a single argument as well. Okay, so there is some default value here. What's the default value? I divide 1 by the given argument. Okay, so that means that when I do comp ink, and if I put 2 here, okay, so I will divide 1 by 2, 1/2, plus add 1, which is 1. That's the second thing that the composition does. So I get 3/2. Yeah, that's it looks familiar. That's here as well. Okay, so that's the first thing. Well, you have division that takes just 1 argument. Maybe the best thing to understand this composite function is let's look at the mathematical notation. That's clear and concise. So we have f of x, which is 1 divided by x, and we add 1. So we can calculate f of 1. That would be just 2. We did this. And then we iterate this function. So we take the value. That is, we calculate the f of 1. So that will be the f of 2, which is 3/2. And if we plug that in again, f, which is the f of 1, that will be 5/3. So that actually we can confirm this is 1, 2, 3/2, 5/3, and it's 8/5. Well, if we continued, that's what we would get. So the only remaining question, now we see how the code works. Why does this converge to the golden ratio? And it's actually a very simple argument. This is continued fractions. So if we take we say that r is the value when we iterate this infinitely many times. We take the output and put it back into the function. So this corresponds to this continued fraction. This is what we are doing, and it's a very nice looking figure. But it is a very simple argument. If you look at it, what's the shape of that? Well, if you call this whole thing r, which is an infinite continued fraction, and you just take what's under the first was the denominator of the first fraction, and this will be this whole thing, right? Which is actually, because it's infinite, is the whole thing itself. So I can write this as r equals 1 plus 1 over r. Again, that's a trick because of infinity. And once you have that, well, you realize that you have a nice quadratic equation. You can solve it, and you will have the positive solution, and that can be defined as the value of this continued fraction. Okay, so it is actually not extremely complicated. Probably the unusual bit is that division can take only one argument, so that makes it happen. And iterate is sometimes hard to imagine, but it is true. So the tweet was correct, and it really contains an interesting piece of mathematics.